Hi friends, welcome to this series on data structures decoded. I'm Dr. Sandeep, Dean R&D, Professor in Sri Krishna Institute of Technology, Bengaluru, welcoming you to this series. Welcome. So, what data structure is? So, let's have a brief introduction of it. Data structure is a specialized, organized way of storing, managing, and accessing the data in a computer so that the operations like insertion, deletion, searching, sorting can be performed more efficiently. Data structures also define the relationship between the data elements, how they are stored in the memory, and the algorithms used to manipulate these data. The key characteristics of the data structures, it's a organization. Data is structured to reflect logical relationships. For example, sequential order in arrays, hierarchical order in trees, etc. As far as efficiency is concerned, it optimizes the time as well as space efficiency for any specific operations. So we commonly are interested in optimizing the time as well as the space, the speed with which any operation is performed, and the memory occupied by the data so that a particular operation is performed. So we would like to have very high speed and a small memory requirement. And for such efficient working, we do use what we call data structures. How they are used, we look in detail in the series. Next, the data structures provide abstraction. It hides implementation details while exposing the operations. Like if you just say push onto the stack, we don't have to worry exactly where in the memory the data is pushed and where and how it is transferred to that memory location and all that. But we only worry about pushing onto the stack, and whenever required, we just pop it. So when I say push onto the stack, some actions happen, and those actions, what they happen, are not made known to the user, so that user don't have to break his head to understand how all these things are happening. They are not required for any user to know. The user just want to use the data. So how it is stored, where it is stored, all that are not a required thing for a user. So data structures are a very good abstraction providers. So the natural question, why do we require data structures? Why does it matter? So one thing is about the performance. So if we choose a right data structure, we can convert an inefficient algorithm into an efficient one. So if we have a proper data structure, then any operation being performed on the data using some algorithm can improve its efficiency because of usage of appropriate data structure. How we look in this whole series, how each data structure helps in improving the efficiency of the algorithms and all that. Now, coming to the real world cases, arrays can be defined as storing pixel data in images, so they are stored in the array form. Graphs can be used for a social network representation where the users are represented as nodes and friendship among the users as the edges. So we can make use of the graph data structure when we are talking about the social network and all that. Hash table has a good usage in database indexing and it helps in faster searching. And the data structure matters in solving the problem. It is critical for coding interviews, optimizing software, games, and operating systems, etc. So, data structure being the base of any computer science world, it's a favorite of any interview board when they are selecting an appropriate candidate. The first thing they look is how strong a candidate is in the foundation, that is the data structure. So, data structures is one of the important topics or one of the favorite topics of any interview board for identifying the gem out of a group of candidates. And it's also useful in optimizing the softwares like games or operating systems and all that. So, more official details about the data structure, definitions, and all will follow in the coming sessions. So, as of now, that's it. So, if you feel the series going to be useful, so please press the like button, subscribe the channel, and please share the information with your friends. Thank you.